So this is Lab 6 for Mastering Electronics, and this is Austin Petronic. Right here we have a transistor, and we're trying to, this is like the current source, essentially, model. So I'm measuring the voltage across VC in here, which I'll show a diagram of, and I can measure that using our voltmeter. And then I also measure across VE, which is this resistor here. You'll see this entire circuit, so we have VC, which comes into the collector side of the transistor, so there's RL, which is a variable resistor here. Additionally, on the base side of the transistor, we have a voltage divider, so we have R1 here, and then R2, which is these two in series. And then on the emitter side, we have RE here, which is connected to ground. And that's our circuit. So this is part B, another current source with a transistor. So this is set up very similarly to the first one, except instead this time we've hooked it up to our oscilloscope power source. So now it's outputting 5 volts. The setup itself is pretty much the same. We've only changed our R2 value. So now this is, we have a 10K resistor as R1 and a 9.2 equivalent resistance for R2. And so like before, we have a potentiometer, so we can vary our input through the collector. And so we'll measure the voltage through the collector arm. In this case, it's about 1.307. And we'll also measure the voltage across the emitter, or the emitter arm, sorry. So this is about 1.592 volts. And we do this 10 times from 0 to 2.5 kilo ohms here on our potentiometer, and we're just measuring, or we're varying that resistance. So at this case, we had a resistance of about 840 ohms. So for part C of this lab, we're making a voltage amplifier. So in part A here, we're measuring the V input and VE for the voltage amplifier in response to a 10 kilohertz signal with a 0.5 volt peak to peak. So you can see the response here. V input is the yellow trace, VE is the blue trace.
So you can notice here that the blue trace has a DC offset of about 0.67-ish in the negative side, and its phase follows the input, as does its gain.
Likewise, in part B, we're measuring V input and VC this time. So if you look at the trace here, you can see yellow trace again is V input, blue trace is VC. You'll notice that VC has a complete phase shift.
Additionally, it has a gain of about 2 and is completely inverted, with a DC offset as well.
So for part 3 of part C, the voltage amplifier, we also did a network sweep from 10 kilohertz to 3 megahertz, and so this is measuring V input and VE. You can see there's not much happening in this case. They're both in phase, and there's no gain.
Lastly, we looked at the gain with VC and V input. You notice here that VC has a gain of about 6 decibels, which was predicted in the lab report, and has a complete 180-degree phase shift, which was also predicted.